Today we're going to talk about area and perimeter again, except we're going to talk about optimizing. So when we talk about optimizing, it just means we want to make the most of what we have. And sometimes you might have to do certain things and choose certain shapes so that it would. So let's consider this problem here. We have a gardener who wants to determine the greatest rectangular area that can be enclosed by a given length of edging. Or we have a dog breeder who wants to make a rectangular training pad with a given area, but they want to have the least amount of perimeter because the more material you buy for perimeter, the more it's going to cost. So optimization, one way we can define it is making the most out of a situation where we have a constraint. Okay, so let's take a look at this video. In this video, we're going to have 20 meters of 1 meter fence pieces. So we're going to watch the video and we're going to just track down what the length is and so length, width, and the area. The perimeter is fixed by 20 meters. And generally, when you have a fixed amount of pieces for the perimeter, you often want to maximize the area. Now, if you could, while you are watching the video, you could probably copy some of these down, and then we'll have our completed chart. Okay, so premise of this is if you have a fixed perimeter, using a square will give you the largest area. So here we have 20 pieces of fencing. Construct as many rectangles as you can. Record your findings. So pause your video and create a chart like this. Okay, I've created a rectangle that has 20 units in total. Oops, that was going really fast. Hey, now this one we have 2 as our width and 8 1 meter pieces as our width. Okay, this one, 3 now for our width and 6 or 7 for our length. Area is 21 units. Okay, the next one, we have 4 as our width and 6 as the length. So that gives us 24 square units. Okay, 20 units, we have 5 for the length, 5 for the width. This gives us a total area of 25 square units. And we could continue doing the process, but everything just repeats itself, but along in the other orientation. Okay, so this is what the chart should look like. We'll copy this out in a bit. And so the conclusion, the largest area that was created was a square. Right, so let's fill in the chart here. Our first one, we had a length of 9. The width was 1, area is 9. When we had a length of 8, width was 2, area became 18. When we had 7, width was 3, area was 21. 6 by 4, that gave us 24. When we had 5, the width was also 5, our area is 25. So we can go back now. Length is 4, that means our width would be 6. Area is 24. You see that it's kind of repeating itself again. So 3, 7, and 21. 2, 8, 16. And then 1, 9, and 8. 1, 9, and 9. Okay. In the middle, we have our maximal area. And we see that all the other ones, they're getting bigger and bigger, but once it hits 5 times 5, the area peaks and then it goes down again. Let's take this information and we're going to graph it. Instead of using, so what I'd like to use is I'm going to use length. And I'm going to use, use x is equal to length and y is equal to area. So we had 9 and 9, 8 and 18, 7 and 21. What you notice here is it looks a bit like a parabola. We're going to use the regression line to trace the shape. A regression line just means I'm going to create a shape that looks like this. You might remember we're taking y1 and we're using our squiggly, ax1 plus bx1 plus c. Oops, and then this is squared. So you can kind of tell this is a bit of a parabolic shape. And in this parabolic shape, I see that I reach a maximum at 5 and 5, which gave us 25. So let's answer some questions about the graph that we had. In this example, we had a perimeter of 20 meters. Now, if you know the length, then you can always find the width, because we know that with a rectangle, perimeter is equal to length plus width plus width, or I could say P is equal to 2L plus 2W. So the relationship has to be these two. So let's say that I have 20 as my perimeter. When it says show the relationship between the length and the width, it just means write an equation that will express the length as the width or the width as a length. So let's use this second equation here. P is equal to 2L plus 2W. Now I know that P is 20 and 2L plus 2W is equal to the 20. So if I want to express this as an L, I can rearrange this equation. So I have negative 2L is equal to 2W minus 20. Let's divide both sides by negative 2 now. So length is equal to 2W minus 20 over negative 2. And I can simplify that more into negative W plus 10. Now, based on the equation that you developed in number 1, write an area to calculate the write an equation to calculate the area only using length. So remember, we said that area is equal to length times width. Now, we also know that the length is equal to negative W plus 10. So I can rewrite this and say area is equal to negative W plus 10 times the width. Area is equal to negative W squared plus 10W. I have area now, and I've only got one variable. I've expressed it in terms of width, but I could express this in terms of length as well. So let's say I was doing it in length. I would have width is equal to 10 minus L. Okay, so another option I could have A is equal to length times 10 minus L. So area is equal to 10L minus L squared. We've expressed area either in terms of the width or in terms of the length. Same thing, just using a different variable. So based on the parabola that we had, what's the maximum area? So if I go back to this, when I go back to this slide, I see that my maximum area here is 5, 5. 5 and 5 gave us 25. So we can say the maximum area is made when we have length and width of 5 meters. And then we could say the maximum area is 25 meters squared. And I guess I kind of jumped ahead because the next question is asking, what were the dimensions that produced the area? Well, we know that the length is equal to 5 meters. And in order for us to get 5 meters, 5 meters and something else to get us 25, our width would also have to equal 5 meters. Okay, so all of that was to demonstrate the point that when we have a perimeter, the square will always give you the maximal area. It's not always that you want the maximal area, but if you did want the maximal area, you would make a square. So let's do two of these as an example. What are the dimensions of a rectangle with a what's the dimension of a rectangle with a perimeter of 20 meters and a maximum area? What is the area? Now, I know that the perimeter of a square is equal to 4 times side. So I could say 20 is equal to 4s. And then when I solve it, 20 divided by 4 is equal to s. S is equal to 5. So because the side is 5, I can also get that for my area. My area of a square is going to be 5 squared. So the area is 25 meters squared. Okay, for the perimeter of 87 inches, what are the dimensions of the rectangle with the maximum area? What is this area? Now, once again, rectangle, we've developed the fact that the square is the special rectangle that gives us the maximal area. So because that's the case, I know that I'm going to have perimeter is 4s, where s is the side. I have 87 divided by 4, and that's equal to s. So in this case, 87 divided by 4, the side that we have is equal to 21.75 inches. So what's the area? The area is going to be length times width, but in this case, the length and the width are the same. So because they are the same, 21.75 times 21.75, or I could say 21.75 squared. So the area of this rectangle, 473.1. I'm going to round that. So square inches. Okay, I'm going to give you a moment. Please try this. For each perimeter, find the dimension of the rectangle with the maximum area. What is the area? Great, let's quickly take these up. Now, because these are all going to be a square shaped, all we need to do to find the side is to take each of the perimeters and divide it by 4. So number 2, our side is going to be 27.5, and then our area is 27.5 squared. So 27.5 squared gives us total area of 756.25 square feet. Okay, side for this one, 25 divided by 4, 6.25. Area is going to be 6.25 squared. So 39.1 square meters. And then our last one, the side here, 745 divided by 4. Our side is 186.25. And the area 186.25 squared. 34,689.1 square yards. Okay, now we're going to do a question similar now, but this time I want a minimum perimeter. So sometimes you want to have a small perimeter, but you're given an area that's fixed. So an example of this would be, suppose you had 36 1-meter square tile, and you wanted to build the largest patio with the minimal perimeter. What is the dimension of the patio and what's the perimeter? So the constraints that you have is that you've got only 36 of these tiles. And so because you've got 36 of these tiles, the maximum area you could have is 36 meters squared. Okay, let's watch the video here to illustrate that. Okay, if you have a fixed area, a square gives you the minimal perimeter. So once again, square is the optimal shape. Now in this situation, you have 36 square tiles. You can create as many rectangles as you can, but you have to use all of the pieces. And then you're going to record your findings. Okay, so create a table like this one. You're going to have, sorry, let's go back a tad. You have your area, length, width, and perimeter. So perimeter is what we want to maximize, or sorry, what we want to optimize. We want the smallest perimeter possible. Okay, so 36 tiles. Let's say I place this all in a straight line. I have 36 units as the length, and the width is 1. So the area is 36 square units. Okay, perimeter. Let's backtrack a bit. Perimeter here, I took the sides and I added it because I know that the perimeter is all of the sides added together. Okay, second option. Let's say I put this in a row, 2 rows of 18. Area is 2 times 18, so 36 square units. I have 2 plus 2 plus 18 plus 18. So our perimeter, 40 units. Okay, let's say I had 3 rows of 12. The area I have is 36 units again, but my dimension is now 3 by 12. And so my perimeter is going to be 30 units. Okay, let's do it by 4 rows of 9. 4 rows of 9, I have 9 plus 4 plus 9 plus 4. Perimeter is 26 units. Okay, let's say I did it with 5. It doesn't work. I've kind of got one tile that's left out. So that actually makes it a bit more of a surface area. Couldn't use all the rectangles to create the tiles. Okay, now let's say I used 6. I would create a square with 6 rows of 6. Well, 12 went with 2, I think. No, 12 went with 3. Perimeter of 30. So these were all of the ones. We're just going through all of this again. Okay, so if you look at the chart, this is the chart that has all of the data. Minimal perimeter is 24. And we got that when we had the square of 6 by 6. Okay, so conclusion, a square gives you the smallest perimeter for a fixed area. Okay, let's finish this. 1, the perimeter was 74. Width of 2 now, 18 plus 18 plus 4 and 4, 36, 40. 12 and 3, 30. When we had 4, it was 9 and 4, 26. 5 didn't work. Then we had 6 and 6. So the perimeter, 24. Now we're going back. If we had 4 and 9, 26 again. 3 and 12 is 30. 2 and 18 is 40. And 1 and 36, 74. Great. Let's follow up using with some comprehension questions. Now we know that the area is fixed at 36 meters squared. If you know the width, write an equation to find the length. So remember, area is equal to length times width. So I could substitute it in and say I have 36 is equal to length times width. Now, if I knew what length was, if I knew what the width was, that would be some sort of number. And I could rewrite it as length is equal to 36 over W. So using the equation developed in number 1, write a new equation using only the length for calculating the perimeter. So we have area is equal to length times width. I could rewrite it as 36 over W is equal to W. Oops, I made a mistake. I'm not talking about the area. I'm talking about the perimeter. Number 2, using the equation developed in number 1, write a new equation using only length for calculating the perimeter. So let's revisit perimeter. Perimeter is equal to 2 lengths plus 2 widths. Okay, so if I'm going to express this as width or as length, I have the length is 36 over W. So I have 2 times 36 over W plus 2W. Okay, let's rewrite this again. 72 over W plus 2W. Okay, so this is the equation that we have, expressing it as a width. Now we could do that the same if we were with length. So I would be able to rewrite this as W is equal to 36 over length. So we would be substituting it into the width instead, and we would have L's instead of W's. Okay, graph the results on the following side. What's the minimum perimeter for the fixed area? So we did trial and error just now when we were using this table. If I'm using a graph to do it, I'm going to type this equation into the graph to find what the minimum area is. Okay, so perimeter is equal to 72 over W plus 2W. Okay, I'm going to substitute instead of W, I'm going to use X. Now we know that our X and Y coordinate, X coordinate, is the width, and our Y coordinate is representing the perimeter. Okay, I zoomed out so that I was able to see the graph. Now, because this is geometry, I know that I can't have negative area and I can't have a negative width. So the only answers that are valid is anything in quadrant 1. Okay, so according to quadrant 1, my lowest point on the graph is 6 and 24. So what that tells us is when I've got the width of 6, I'm going to have the minimum perimeter of 24. Okay, the dimension for the rectangle that gives the minimum perimeter is 6 meters by 6 meters. And the perimeter is 24 meters. Okay, so let's review that principle again. For area, if we're looking for a rectangular shape, the square is going to always give us the minimal perimeter. So let's say I have an area of 45 meters squared. What's the minimum perimeter? So area is equal to 45. Perimeter is 2L plus 2 width. But this is a square. So I can say the perimeter is equal to 4S. I can also say that my area, because it is a square, my area is side squared. Let's substitute these in. So I could say 45 is equal to side squared. So I have the square root of 45 is equal to S. And we have square root of 45, approximately 6.7. Okay, what's the perimeter now? Perimeter is equal to 4 times 6.7, 26.8. Let's do another question similar to that. I have a 169 square inch rectangle, and I want it to have a minimal perimeter. Find the dimensions of the perimeter. So I know that the area is 169. I also know that area is equal to length times width, but in this case, this is side squared because we're using a square. So that means my side is equal to the square root of 169. And we have 13 inches. Let's substitute this into our perimeter equation so that we could solve it. So perimeter is equal to 4 times 13. So we have P is equal to 52. Okay, slide number 11. I would like you to try these, find the perimeter, and find the dimension of the rectangle. In practice question number 1, you're going to be considering these, and I do want to give you a heads up that it may require a little bit of algebra. Okay, so get to it, and I'll take a look at your. Hi class, I'm not going to take up slide 11, but I do want to mention a few things for slide number 12. So slide 12, I want you to practice with some of these questions. It says, a gardener uses 24 meters of fencing to enclose a rectangular vegetable garden. Some possible rectangles are shown below. Determine the missing dimensions for each diagram. Okay, so I know that there's 24 meters altogether. I have my first one. The first one would have 10 meters and 10 meters here. It doesn't indicate what I have here, but I need to use algebra to solve it. So you can probably figure out in your head that this will take up 24 meters already. So the remaining 4 meters has to be divided evenly, one for each side. So I have a 10 by 2 rectangle. You're going to be doing the same thing for each of these. You could either do it algebraically or you could do it intuitively. Okay, the second thing is to calculate the area of each garden. So once you've found the dimension, you know that the perimeter is 24. This is fixed. I want you to calculate the area of the garden. Hi, Mina. I just noticed that I had muted, and so you didn't get to hear it. I'm going to say that again. So slide number 12, we have practice question number 1 and 2. A gardener uses 24 meters of fencing to enclose a rectangular vegetable garden. Some possible rectangles are shown below. Determine the missing dimension for each diagram. So we know that as a rectangle, we have two sides that are similar. So two sets of two sides. In my first example, I have 10 here. So on this side, this is also going to be 10. The two sides here, I can use algebra to solve because I know that I have 10 plus 10 plus an unknown width, another unknown width, and this has to equal 24. So I have 2w is equal to 24 minus 20. 2w is equal to 4 and x is equal to 2. So that's one way to do it. Another way is to do it intuitively because you know that these two together adds up to 20. And so I've got 4 units left. And the 4 has to be divided 2 ways into 2 parts. So I have a 10 by 2. Okay, so you're using that to figure out the missing sides. Then you're going to calculate the area for each garden. And that's question number 1 here.